Hi everyone, it's Mr. Baker here. Today we're going to be looking at the wave equation. Okay, so today we're going to be looking at the wave equation. So first of all then, let's have a look at these quantities that we need to know a little bit about before we look at the equation itself. So we've got speed, we've got frequency, and we've got wavelength. First of all, let's have a look at what the symbol is for each of these. Maybe you want to have a go at this before we go through it. If you do, then just pause the video and then just try and have a go, write it down, see if you can link up the right symbols and the units to the quantities, and then I'll show the answer. So if you can do that, pause now. Okay, right, so let's go through it. So speed, which one did you put as a symbol for speed? Yes, so speed, the symbol for speed is V, like V for velocity. We use V for speed because velocity is the speed in a certain direction, and so that's the symbol we use. And the units for speed are meters per second. It's a certain distance you've travelled in a certain amount of time. That's what speed is. That's the definition of speed. All right, frequency. What have we got for frequency? Well, probably a little bit obvious. F for frequency, that works, doesn't it? And the unit for frequency is hertz. It's the number of things in a second, basically, is what frequency is. And we use the unit hertz. And so that leaves wavelength as our symbol lambda, L-A-M-D-A, lambda. And the unit for that is meters. It's a length, it's a distance, so its unit is going to be in meters. Okay, hopefully you got that. Let's have a little look at an example then. So how do we calculate speed, the speed of a wave? So these waves are travelling along the surface of a pond. The length of each wave is 0.5 meters. 2 waves pass the swan each second, so the frequency is 2 hertz. Okay, so we've got the length of the wave is 0.5 meters, and we've got that 2 of them go past the swan every second. So this means that the wave travels 1 meter each second. So the speed of the wave is 1 meter per second. So speed equals frequency times wavelength. So this is what we've kind of come up with, that the speed is 1 meter per second, and that's because we have 2 waves passing every second, and each wave is 0.5 meters. So we kind of have come up with our little equation that speed equals frequency times wavelength. And this is what our equation is. So the wave speed equals the frequency times the wavelength, and we can use our symbols that we've just looked at. So V for wave speed, F for frequency, and lambda for the wavelength, and we can use those instead. And we've also just said that the units, wave speed is measured in meters per second, frequency is measured in hertz, and wavelength is measured in meters. Right, so to make it a little bit more difficult at GCSE, you might have to look at some different types of units. So a kilo means 1,000 times something. So you might get kilometers or kilohertz. So that'd be 1,000 meters or 1,000 hertz. Mega means a million. So you times whatever it is by a million. So if you've got a capital M in front of it, mega, then it would be times by a million. So kilometers, for example, km, that would be 1,000 meters. Megahertz, that would be a million hertz. Giga means a billion, so you might see that one as well. And giga, you times it by a billion, so that's 9 zeros at the end of it. And you might get gigahertz or something like that. Okay, so let's have a look at an example. These waves are rippling across a pond. The frequency of the waves is 0.2 hertz, and the length of each wave is estimated at 0.15 meters. What's the wave speed? If you want to have a go at this, and pause the video and have a little go, and I'll go through it with you in a second. Okay, so I'm going to go through it now. So we've got our equation, wave speed equals frequency times wavelength. And then we would put what we know into it. So we know that the frequency is 0.2 hertz, and we know that the wavelength is 0.15 meters. So we'd put those two in, and then we'd get our answer as 0.03 meters per second. So this is how I would always do any type of equation. Write out the equation, write out what you know, put the numbers in, and then you'll get some marks for that, even if you do the calculation wrong afterwards. So this is what you should be able to do by the end of this lesson. Then you should be able to define wave speed, wavelength and frequency, and be able to recall those units, and you should be able to use the wave equation. Okay, so that's this lesson over. Thanks very much. I've been Mr. Baker, and I'll see you next time.